Listen to part of a lecture in an environmental science class.
Now, we've been talking about the loss of animal habitat from housing developments, growing cities, small habitat losses. But today I want to begin talking about what happens when habitat is reduced across a large area. There are, of course, animal species that require large areas of habitat, and some migrate over very long distances. So what's the impact of habitat loss on those animals that need large areas of habitat? Well, I'll use the hummingbirds as an example. Now, you know a hummingbird is amazingly small, but even though it's really tiny, it migrates over very long distances, travels up and down the Western Hemisphere, the Americas, back and forth between where it breeds in the summer and the warmer climates where it spends the winter. So we would say that this whole area over which it migrates is its habitat, because on this long-distance journey, it needs to come down to feed and sleep every so often, right? Well, the hummingbird beats its wings, get this, about 3,000 times per minute. So you think, wow, it must need a lot of energy, a lot of food, right? Well, it does. It drinks a lot of nectar from flowers and feeds on some insects, but it's energy efficient, too. You can't say it isn't. I mean, as it flies all the way across the Gulf of Mexico, it uses up almost none of its body fat. But that doesn't mean it doesn't need to eat. So hummingbirds have to rely on plants in their natural habitat. And it goes without saying, but, well, the opposite's true as well. Plants depend on hummingbirds, too. There are some flowers that can only be pollinated by the hummingbird. Without it stopping to feed and spreading pollen from flower to flower, these plants would cease to exist. But the problem, well, as natural habitat along these migration routes is developed by humans for housing or agriculture or cleared for raising cattle, for instance, there's less food available for migrating hummingbirds. Their nesting sites are affected too, by the same sorts of human activities. And all of these activities pose a real threat to the hummingbird population. So to help them survive, we need to preserve their habitats. And one of the concrete ways people have been doing this is by cleaning up polluted habitat areas and then replanting native flowers that hummingbirds feed on. Promoting ecological tourism is another way to help save their habitat, as the number of visitors, ecotourists, who come to hummingbird habitats to watch the birds, the more the number of visitors grows, the more local businesses profit. So ecological tourism can bring financial rewards. All the more reason to value these beautiful little creatures and their habitat, right? But to understand more about how to protect and support hummingbirds the best we can, we've got to learn more about their breeding, nesting sites, and migration routes, and also about the natural habitats we find there. That should help us determine how to prevent further decline in the population. A good research method, a good way to learn more, is by running a banding study. Banding the birds allows us to track them over their lifetime. It's a practice that's been used by researchers for years. In fact, most of what we know about hummingbirds comes from banding studies, where we capture a hummingbird and make sure all the information about it, like its weight and its age and length, are all recorded and put into an international information database. And then we place an extremely lightweight band around one of its legs. Well, what looks like a leg, although technically it's considered part of the bird's foot. Anyway, these bands are perfectly safe, and some hummingbirds have worn them for years with no evidence of any problems. The band is labeled with a tracking number. Oh, and there's a phone number on the band for people to call, for free, to report a banded bird they've found or recaptured. So when a banded bird is recaptured and reported, we learn about its migration route, its growth, and how long it's been alive, its lifespan. One recaptured bird had been banded almost 12 years earlier. She's one of the oldest hummingbirds on record. Another interesting thing we've learned is that some hummingbirds, they no longer use a certain route. They travel by a different route to reach their destination. And findings like these have been of interest to biologists and environmental scientists in a number of countries who are trying to understand the complexities of how changes in a habitat affect the species in it.
Listen again to part of the lecture. Then answer the question.
So, hummingbirds have to rely on plants in their natural habitat. And it goes without saying, but, well, the opposite's true as well. Plants depend on hummingbirds, too.
What does the professor imply when she says this?
And it goes without saying.
Listen to a conversation between a student and a professor. Hey, Ellen, how are you doing?
Oh, pretty good, thanks. How are you?
Okay.
Did you have a chance to look at my grad school application? You know, the statement of purpose I wrote?
Well, yeah, in fact, here it is. I just read it.
Oh, great. What did you think?
Basically, it's good. What you might actually do is take some of these different points here and actually break them out into separate paragraphs. So, one, your purpose for applying for graduate study. Why do you want to go to graduate school and an area of specialty, and why you want to do the area you're specifying, and what you want to do with your degree once you get it.
Okay.
So they're pretty clear on those 4 points they want.
Right.
So you might just break them out into, separate paragraphs and expand on each point some. But really what's critical with these is that you've got to let yourself come through. See, you got to let them see you in these statements. Expand some more on what's happened in your own life and what shows your motivation and interest in this area, in geology. Let them see what captures your imagination about this field.
Okay, so make it a little more personal. That's okay?
That's fine. They look for that stuff. You don't want to go overboard.
Right.
But it's critical that somebody sees what your passion is, your personal motivation for doing this.
Okay.
And that's got to come out in here. And let's see, you might also give a little, since this is your only chance to do it, you might give a little more explanation about your unique undergraduate background. So, how you went through, the music program, what you got from that. Why you decided to change. I mean, it's kind of unusual to go from music to geology, right?
Yeah, I was afraid that, maybe the personal type stuff wouldn't be what they wanted, but...
No, in fact, it's... give an example. I had a friend when I was an undergrad, went to medical school, and he put on his med school application, and he could actually tell if somebody actually read it, because he had asthma, and the reason that he wanted to go to med school was he said he wanted to do sports medicine because he had this real interest. He was an athlete too and wanted to help athletes who had this physical problem. And he could always tell if somebody actually read his letter because they would always ask him about that.
So something unique.
Yeah. So see, that's what's good. And I think for you probably, your music background's the most unique thing that you've got in your record.
Right.
So you see, you got to make yourself stand out from a couple of hundred applications. Does that help any?
Yeah, it does. It gives me some good ideas.
And what you might also do, too, is, you might get a friend to proof it or something at some point.
Oh, sure.
Also, think about presentation, how the application looks. In a way, you're actually showing some other skills here, like organization. A lot of stuff that they're not formally asking for, they're looking at. So your presentation format, your grammar, all that stuff, they're looking at in your materials at the same time.
Right. Okay.
Listen to part of a lecture in an art history class.
Today, we'll continue our examination of ancient Roman sculpture. We've already looked at portrait sculpture, which are busts created to commemorate people who had died, and we've looked at relief sculpture, or sculpting on walls. And today, we look at yet another category of sculpture, copies. Roman sculptors often made copies of famous Greek sculptures.
Why did they do that?
Well, no one knows for sure. You see, in the late 4th century BC, the Romans began a campaign to expand the Roman Empire. And in 300 years, they had conquered most of the Mediterranean area and parts of Europe. You know the saying, to the victor belong the spoils? Well, the Roman army returned to Rome with many works of Greek art. It's probably fair to say that the Romans were impressed by Greek art and culture, and they began making copies of the Greek statues. Now, the dominant view in traditional art history is that Roman artists lacked creativity and skill, especially compared to the Greek artists who came before them. Essentially, the traditional view, a view that's been prevalent for over 250 years, is that the Romans copied Greek sculptures because they couldn't create sculpture of their own. But finally, some contemporary art historians have challenged this view. One is Elaine Gazda. Gazda says that there might be other reasons that Romans made copies. She wasn't convinced that it was because of a lack of creativity. Can anyone think of another possible reason?
Well, maybe they just admired the sculptures. They liked the way they looked.
Yes, that's one of Gazda's points. Another is that while nowadays reproduction is easy, it was not so easy in Roman times. Copying statues required a lot of skill, time, and effort. So Gazda hypothesizes that copying didn't indicate a lack of artistic imagination or skill on the part of Roman artists, but rather the Romans made copies because they admired Greek sculpture. Classical Greek statues represented an idealization of the human body and were considered quite beautiful at the time. Gazda also believes that it's been a mistake to dismiss the Roman copies as, copies for copy's sake, and not to consider the Roman function and meaning of the statues.
What do you mean, the Roman function? Weren't they just for decoration?
Well, not necessarily. Under the Emperor Augustus, at the height of the Roman Empire, portrait statues were sent throughout the empire. They were supposed to communicate specific ideas about the emperor and the imperial family, and to help inhabitants of the conquered areas become familiar with the Roman way of life. Roman coins were also distributed throughout the empire. Anybody care to guess what was on them?
The emperor's face?
That's right. The coins were easy to distribute, and they allowed people to see the emperor, or at least his likeness, and served as an additional reminder to let them know, who was in charge. And the images helped people become familiar with the emperor. Statues of him in different roles were sent all over the empire. Now, actually, some Roman sculptures were original, but others were exact copies of Greek statues. And some Roman sculptures were combinations of some sort. Some combined more than one Greek statue, and others combined a Greek god or an athlete with a Roman's head. At the time of Julius Caesar, it wasn't uncommon to create statues that had the body of a god and the head of an emperor. And the Romans were clever. What they did was they made plaster casts from molds of the sculptures. Then they shipped these plaster casts to workshops all over the empire, where they were replicated in marble or bronze. And on some statues, the heads were removable. They could put an emperor's head on different bodies, showing him doing different things. And then later, when the time came, they could even use the head of the next emperor on the same body.
Listen again to part of the lecture, then answer the question.
Essentially, the traditional view, a view that's been prevalent for over 250 years, is that the Romans copied Greek sculptures because they couldn't create sculpture of their own. But finally, some contemporary art historians have challenged this view.
What does the professor imply when he says this?
But finally, some contemporary art historians have challenged this view.
Listen to part of a talk in a botany class.
Okay, so we've talked about some different types of root systems of plants, and I've shown you some pretty cool slides. But now I want to talk about the extent of the root system, the overall size of the root system, the depth. I want to tell you about one particular experiment. I think you're going to find this pretty amazing. Okay, so there was this scientist. This very meticulous scientist decided that the best place to see a whole root system, to actually see how big the entire system got, the best place would be to grow it where?
Water?
In water. So he took rye plants, it was rye plants, and he started growing them in water. Now, you've all heard of growing stuff in water before, right?
It's done commercially, right? Like to grow vegetables and flowers?
Right. They grow all kinds of commercial crops in water. So, if you're growing things in water, you can add the fertilizer. What do you need to do to that water besides put fertilizer in it? Anyone ever actually tried to grow plants in water? You must bubble gas through it. You must bubble gas through it. So, gas, you have to bubble through. Think about the soil we talked about last week, about growing plants in soil. Think about some of you who have killed your favorite houseplants because you love them too much. If you overwater, why do your favorite houseplants die?
Oh, no oxygen.
Not enough oxygen for the roots, which do what 24 hours a day in all seasons?
Respiration?
Respiration. They breathe. So if you just stick rye plants in water, it doesn't make a difference how much fertilizer you add. You also need to bubble gas through the water. So they have access to that oxygen. If they don't have that, they're in big trouble. Okay, so this scientist, grew a rye plant in water so he could see the root system, how big it got, its surface area. I read about this, and the book said 1,000 kilometers of roots. I kept thinking, this has to be a mistake. It just doesn't make any sense to me that could be right, but that's what all the books have, and no one's ever corrected it. So let me explain to you about this rye plant. If you take a little seed of many grasses, and remember, rye is a grass. If you take a tiny little seed and you germinate it, actually, take one of my least favorite grasses that starts growing about May. What's my least favorite grass that starts growing about May?
Crabgrass.
Crabgrass. Remember how I showed you in the lab, one little seed starts out producing one little shoot, then at a week or so later, you've got about 6 shoots. And then 3 weeks later, you've got about 15 shoots coming out all directions, like this. All those little shoots up there? Well, that's what they did with the rye. And the little seedlings started, and pretty soon there were several shoots, and then more shoots. In the end, that one single seed produced 80 shoots, with an average of 50 centimeters of height from one seed. 80 shoots coming out. Average 50 centimeters high. When they looked at the shoot versus the root surface, they found that the shoot surface, with all of its leaves, had a total surface area of about 5 square meters. Now, here's the biggie. When they looked at the root surface area, you would expect that the root and the shoot would be in balance, right? So they should be pretty close in terms of surface area, right? What's that? Did somebody say no? Well, you're absolutely correct. Instead of 5 square meters, the root system was found to have more than 200 square meters of surface area. Where did all of that extra surface area come from? Who did it? Who was responsible for all those extra square meters of surface area? What did roots do to increase their surface area?
Root hairs.
Root hairs, that's exactly it. So those root hairs were responsible for an incredible chunk of surface area. They constantly have to be spread out in the water so they can absorb minerals from the fertilizer. And of course, they need oxygen access as well.
Listen again to part of the lecture. Then answer the question.
What do you need to do to that water besides put fertilizer in it? Anyone ever actually tried to grow plants in water? You must bubble water through it. Bubble gas through it. You must bubble gas through it. So, gas, you have to bubble through.
Why did the professor say this?
You must bubble gas through it.
Listen again to part of the lecture. Then answer the question.
I read about this, and the book said 1,000 kilometers of roots. I kept thinking, this has to be a mistake. It just doesn't make any sense to me that could be right, but that's what all the books have, and no one's ever corrected it. So let me explain to you about this rye plant.
What does the professor intend to explain?
Listen to part of a conversation between a student and a university employee.
Oh, hello. Can I help you?
Yeah. I'm looking for Professor Kirk. Is she here? Is this her office?
Yes, you're in the right place. Professor Kirk's office is right behind me. But no, she's not here right now.
Do you know when she'll be back?
Well, she's teaching all morning. She won't be back until, let me check. She won't be back until after lunch. That's when she has her office hours. Perhaps you could come back then?
Oh, unfortunately, no. I have class this afternoon, and I was really hoping to talk to her today. Hey, do you know if she's accepting any more students into her Introduction to Biology class?
You want to know if you can take the class?
Yes, if she's letting any more students sign up, I'd like to join the class.
Introduction to Biology is a very popular class, especially when she teaches it. A lot of students take it.
Yeah, that's why the registrar said it was full. I've got the form the registrar gave me, to get her permission to take the class. It's all filled out except for her signature. I'm hoping she'll let me in even though the class is full. You see, I'm a senior this year, and this will be my last semester, so it's my last chance.
Oh, wow, really? Most students fulfill their science requirement the first year.
Well, to be honest, I kept putting it off. I'm not really a big fan of science classes in general, and with the labs and everything, I've never quite found the time.
Your advisor didn't say anything?
Well, to tell you the truth, she's been after me to take a class like this for a while, but I'm double majoring in art and journalism, and so my schedule's been really tight with all the classes I gotta take, so somehow I never...
Well, perhaps you could leave the form with me, and I'll see if she'll sign it for you.
I appreciate that, but maybe I should explain the problem to her in person. I didn't want to do it, but I guess I'll have to send her an email.
Not all professors check their emails regularly. I'm not sure if Professor Kirk does it or not. Here's an idea. Why don't you stick a note explaining your situation under her door and ask her to call you if she needs more information?
Hey, that's a good idea. And then I can leave the form with you, if you still don't mind.
Why does the man say this to the woman?
I appreciate that, but maybe I should explain the problem to her in person.